Fine, let us start. Good morning, everyone. Hope you can see my screen. Sorry, good evening, everyone. So, you can see my screen, right? Yes. Yeah, thank you. So, what we will do in the last class, some of you have asked about solving some previous year questions from random variables and random process. And also, few of you have asked from correlation, cross correlation, and network theory. And I think Bunty has sent a few questions, right, from 2022 gate. Some question number 45, 48, and some 55. So what we will do, first we will try to cover the questions asked by Bunty, and afterwards we will try to solve some of the problems from random variables in random process. Maybe in the next class we'll see some problems from networks and cross correlation. Okay, so fine. So this was asked by one of you. So this question is given in GATE 2022 for 2 marks. So a series is given. Consider the following series. That is sigma. Yeah, that is sigma n equal to 1 to infinity n power d by c power n. For which of the following combinations of c and d values does this series converges? Four options they have given. Okay, so it's a summation, infinite summation, n is varying from 1 to infinity, and you have like two constants here. They are c and d. Some constants c and d they have given. Now we need to check for what combination, given combination, it will converge. Converge means, you know, right? You might have studied the convergence of Fourier series and all. So this infinite summation should be a finite quantity. Okay, so the sum, if you add all the infinite terms, it should not be infinity. It should be a finite quantity, right? That's what, right? Convergence means. So convergence means what? If we have some summation, something like this, some sigma n equal to 1 to infinity u of n, something like this, then this entire quantity, so should be less than infinity. It should be finite. Then only we'll say it is convergent. Okay. Now for this we can use ratio theorem, or we can use P series, something is there, P series, something like that. But mostly by common sense, we can say whether it is converging or not. Now, what ratio theorem tells is some sigma n equal to 1 to infinity. un you have, it's infinite summation. That means you have something like u1, u2, so on, un plus 1 plus so on up to infinite terms. Let us say u1 is some finite quantity. We cannot have infinite terms, right? So when we will say converging, now suppose if I take the ratio of two successive terms, suppose if I take un plus 1 by un, that means the ratio of next term by present term. If we take the sum as n tends to infinity, if we take limit n tends to infinity, so what we are doing, we are taking the ratio u of n plus 1 by n as n tends to infinity. If it is less than 1, then we can say it is converging. Okay. If it is greater than or equal to 1 also, we can say it is diverging. You got it right? Let us say some example I'm telling. You have taken with something called, let us say 5. Maybe the next term is 2.5. Like that it is going, and the next term is 1.25. Maybe the next term is 0.625. Like that it is going. So if the ratio of two successive terms it's less than 1 means what? The ratio is less than 1 means what? The values are decreasing, right? Decreasing means if we add them, then it cannot be infinity. Suppose if the ratio is greater than 1, some series is there, let us say 2, 6, then 18, then something like this is, let us say 54, something. See here increasing. The ratio if I take 54 by 18 is greater, it's 3 greater than 1. That means it is increasing, right? So that means it will be divergent. So as it's like, see, converging means, so in signals we will see, let us say n, a discrete signal you take. So if it is something like this, initially you have some finite value at n equal to 1, at n equal to 1. Now as n increases, if it is decreasing, let us say, so on up to somewhere very large n you have taken, still it is decreasing, then we can say it is converges, right? You got it right? So in the other case, if we take something like this, it is like diverging, right? N increases means it will reach to infinity. Convergence means what? As n tends to infinity, that particular term should become 0. Okay. Similarly, here diverging means at n tends to infinity, the particular term will become large. So that's what. So u of n plus 1 by u of n, ratio of next term by present term, as n tends to infinity at very large values of n, if it is less than 1 we can say convergent. Okay, is that okay? So here, so what is our ratio for first option? Option wise we'll check. Now for first option you take, so sigma n equal to 1 to infinity, n power d is what? Minus 1 by c is 1, c power 1 power n. So this is what? Sigma n equal to 1 to infinity. So d is minus 1, right? So 1 by n. So what will happen to this? If we expand this, 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, so on. So large 1 by n plus 1 by n plus 1, so on, like this, right? So definitely we can see it is a convergence, right? When n tends to infinity, 1 by infinity, it will become 0. Or else you can use this ratio theorem. Then what is this? Sigma n, sorry, limit n tends to infinity, u of n plus 1 by u of n plus 1 by u of n. U of n plus 1 is what? Limit n tends to infinity. U of n plus 1 is what? 1 by n plus 1 by n. So it will be limit uh, limit 1 by 1 plus 1 by n. Limit n tends to infinity. Its value is 1. Sorry, everything is okay. Mm. Oh, it will be. So, sorry, but if you see here, definitely this will be less than 1 because n plus 1 by n, whatever may be the value of n, this will be less than 1, right? Because always new denominator is greater than numerator. So denominator is always greater than numerator. So this will be definitely less than 1. This will be converging. Else for this we can use something called P series, I guess. If we have some summation, something like this, 1 by n power p, okay, sigma n equal to 1 to infinity 1 by n power p. If p greater than 1, if p greater than or equal to 1, definitely it will be converging. Okay, and if p less than 1, p is between 0 and 1, it is diverging. Because see, the first case p greater than 1, let us say p equal to 2 only you take. Sigma n equal to 1 to infinity 1 by n square. Then it is 1 by 1 square plus 1 by 2 square 4, 1 by 3 square 9, so on. It converges. Otherwise, the other case is, the second case is, if it is 0 less than p less than 1. Let us say p equal to half you take, 0.5. So that will be 1 by 1 power zero point 0.5, 1 by 2 power zero point 0.5, 1 by 3 power zero point 0.5, like this. Now this will be diverging. Okay. So from here we can say the first one is converging. Now we see second one, c equal to 2 and d equal to 1. Option B we will see, c equal to 2, d equal to 1. So what we get, sigma n equal to 1 to infinity n power d by c power n power d by c power n. So this will be equal to sigma n by c power n to power n. n equal to 1 to infinity. So ratio theorem we will apply, limit n tends to infinity. U of n plus 1. What is term n plus 1? N plus 1 by 2 power n plus 1 by n by 2 power n. So what you get, limit n tends to infinity, n plus 1 by n to 1 by 2. So is this correct? Are we going correct? Can somebody please correct me if I'm doing wrong in this? N plus, so this will be limit n tends to infinity 1 by 2 into 1 plus 1 by n. Okay. So as n tends to infinity, 1 by n tends to 0, that is 1 by 2 into 1 plus 0. So it is 1 by 2. So which is less than 1. So it is converging. Okay. So the second one also converging. Let us see the third one. For third one, c equal to 0.5 and d equal to minus 10. So our summation becomes now for third one, sigma n equal to 1 to infinity n power d is minus 10 by c is 0.5 power n. So this we can say sigma n equal to 1 to infinity. Can we write like 2 power n by n power 10? Right? 2 power n by n power 10. So again, you take limit n tends to infinity u of n plus 1 by u of n. So it will become limit n tends to infinity 2 power n plus 1 by n plus 1 power n into 2 power n by n power 10. So it will be limit n tends to infinity, uh, something like what we get, 2 into n by n plus 1 power 10. Oh, this is also converging. Now we are getting 2 right here. Something is wrong. So limit n tends to infinity 2 into 1 by 1 by 1 plus n power 10. So 2 into 1 by 1 plus 0 power 10. This is 2. This is diverging. So the fourth one, if you see, c equal to 1, d equal to minus 2, c equal to 1, d equal to minus 2. So what we get, sigma n equal to 1 to infinity n power minus 2 by c power to c power n. So this is sigma n equal to 1 to infinity 1 by n square. So using p series, we can say this is converging, right? Okay, that's what we somewhere said here, p series. This one. Sorry, here something wrong I told. P greater than 1 converges. See, if the P series sigma n equal to 1 to infinity, P greater than 1 converges. P greater than 1 converges. So here it is converges. Then the first one diverges, it seems. It's the first one. This one, first one, right? This one, not this one. This one, I guess, first one, right? Okay, for this, what we got is this one, right? But okay, if you apply limit, what you are getting is 1 we are getting. So still we cannot exactly say it is converging if we get 1. So this one, this limit n tends to infinity u of n plus 1 by u of n. For this, if you apply, what you are getting is this one, right? So this we can write like this. So this is 1 by 1 plus this is 0, 1 we are getting. So it is not converging then. Sorry. It is less than 1, then it is converging. See, as actually n by n plus 1 is, sorry, there was some mistake while explaining first. N by n plus 1 is always less than 1, that is for sure. But as n tends to infinity, n by n plus 1 equal to 1, because n tends to infinity means infinity by infinity plus 1. So infinity by infinity, like we can say 1. So limit, how we write that? Limit n tends to infinity n by n plus 1. Generally limits like this will solve, right? 1 plus 1 by n. The limit n tends to infinity, 1 by n tends to 0, this is 1. Right? So, so sorry, then the first option is diverging. The second option is converging. The third option also diverging. And the fourth option is converging. Okay. Option B and D are converging. Sir, can you explain third option? Option C? Yes. Yes, option C, this one, right? N power minus 10 by 0.5 power n. So this I'm rewriting like this. 0.5 power n means 1 by 2 power n. So 2 power n by n power 10. Can we write like this? So for this, limit n tends to infinity, u of n plus 1 by u of n I am taking. So n tends to infinity, u of n plus 1 means 2 power n plus 1 by n plus 1 power 10 divided by 2 power n. Just directly I am writing, it will become reciprocal. So what we get? 2 of n plus 1 is here, 2 power n is here. So it will be 2 into n by n plus 1 power 10. Okay, so we can take in this n common, so I can write this as 1 by 1 plus 1 by n power 10. So as n tends to infinity, 1 by n tends to 0, that we know. So 2 into 1 by 1 plus 0 power 10, so it is 2. So it is greater than 2 we are getting, right? This is ratio, so it is diverging. Okay, actually you can check these theorems, ratio theorem and p series, these two. Mostly by ratio theorem we can solve. P series one, P series convergence is simpler one than ratio theorem. Any doubts in this? Fine, we will move on to the next question. So this question also was asked, question number 48, I think in last class somebody asked. So the question is, reads as follows. This was given in GATE 2022, question number 48. A state transition diagram with three states. Hope you know the state transition diagrams, right? Maybe this you might have studied where state transition diagrams. In digital electronics, have you studied this? Digital circuit design, maybe. Hello? Yes, sir. Yes, sir. Yeah, fine. So a state transition diagram with states A, B, C and transition probabilities P1, P2 up to P7 is shown in the figure. So P1 denotes the probability of transition from state A to B. Okay. For the state diagram, select the statements which is are universally true. That's what they're asking. Now you know, right? So you have three states A, B, C. Let us say you are in state A, and maybe the circuit, let's say circuit is given with some input. Then the circuit may stay in the same state, or it may go to state B, or it may go to state C. Okay, let us say in case of these uh, sequential circuits. So you are in state A, you have applied some clock pulse, then the circuit may stay in the same state, or it may go to any other state. So I'm in state A. So now, so this probability is nothing but this state transition probability is nothing but so sorry, now I am in state A. That means given that I am in state A and I am going to state B. So what is the probability that you are going to state B given that you are in state A? So that is nothing but this probability. Okay. And this one you see, you are in state A. Sorry, you are in state A and some excitation is given. You are staying in the same state. So what is the probability that you are in state A and after let us say next clock pulse, let us say you are in the same state only, that is P of A given A. This one you see P4 is what here, you are in state A, now some clock pulse or excitation is given, you are going to state C. Okay, that means when you are in state A, when some excitation is given, you may go to any of the states or you may stay in the same one. Then what are the sum of transition probabilities? These are called transition probabilities. What are the sum of the transition probabilities? Sum of all the transition probabilities for a state is 1, right? Yes or no? So yes, sir. You are in state A, you may go to state B, or you may stay in state A, or you may go to state C. That means you are in state A, you may stay in state A plus, or you are in state A, given that you are in state A, you may go to state B. Yes, you are in state A, given that you may go to state C. These are the only three possibilities, right? So the sum of all the probabilities is 1. So with so and so probability, you may go to this state or may stay in the same state, like that. So that is true for all. So that is true for all the states. Now let us see. I am writing here. Now let us see for state A, what are the three state transition probabilities? P1 is going from A to B. So P1 is going from A to B. This one. P7 is staying in A only, and P4 is going from A to C. That means P1 plus P4 plus P7 equal to 1. Can I say this for state A? For state A, sum of all state transition probabilities equal to 1. Right? Similarly, for state B, what are the transitions are there? For state B, can you see here? So for state B, the transitions are you may stay in state B only, or you may go to state A, but you cannot go to state C, right? That means for B, I am writing here, you are in state B, let us say, you may go to state A, or you may go to, you may stay in the state B only, or you may go to state C. This equal to 1 sum. So from B, you can go to A with P3 probability. From B, you may stay in B only with P2 probability. From B, you cannot go to C, right? So that is 0 equal to 1. So P3 plus P2 equal to 1. For state A, this is the 1. Similarly, for state C, can somebody tell for state C, what are the three states transition probabilities? You are in state C, you are in state C, you may go to state A, or you are in state C, you may go to state B, or you are given that you are in state C, you may stay in state C only. This equal to 1. So state C to state A, okay, that is P6, that is there, plus state C to state B, you cannot go, 0. The state C to state C, that is P5 equal to 1. So what are three we got? First equation is what? P1 plus P2, P4 plus P7 equal to 1. So option C is correct. P1 plus P4 plus P7 equal to 1. Option C is correct. And another thing is, from here what we got? P2 plus P3 equal to 1 for state B. Similarly, for state C, what we got? P5 plus P6 equal to 1. So from these two, I can deduce P2 plus P3 equal to P5 plus P6. So option A also correct. And any other are there? P2 plus P5 plus P7. So option D you see. P2 plus P5 plus P7. This may or may not be true. Definitely, we cannot say all circumstances this cannot happen. And option B also, all circumstances cannot happen. So, only what they're asking, universally true. These two, any case, whatever may be the probabilities, these two are true. A and C, these can be true. For whatever value the probability value. This B and D may be special cases, they may be equal. Suppose you are selecting anyway P1, P2, P3, all are like probabilities, right? You may selecting such a way that sometimes it they may satisfy, but A and C always satisfy. Is that okay? Yes, sir. Anybody is having any doubts from this? Fine. Then we are moving on to the next question. This is also asked by I think Bunty. So this question was given in GATE 2022 ECE for 2 marks. The question is here: a linear two-port network is shown in Figure A. Okay. Ah, shown in Figure A. So this is the two-port network it is given, and an ideal DC voltage source of 10 volts is connected across port 1. So across port 1, ideal DC source is connected. A variable resistance R is connected across port 2. This one R is a variable resistance connected across port 2. Now as R is varied, the measured voltage and current at port 2 is given in the figure B. This one. So here I2 is entering current in port um, 2. So you can say minus I2 is leaving current from port 2, minus I2 we can say this one. Now what is given in this, when from this figure B, when minus I2, that means the leaving current, you can say when minus I2 is 0, the voltage is 5 volts, output voltage is 5 volts. When I2 is 4 amps or minus 4 amps, output is 4 volts. This is given. Now what they're asking, when the variable resistance R at the port 2 is replaced by a load shown in the figure. Now they are asking, instead of this variable resistance, a load is replaced with some battery and some resistance. Then what is the current I2? So then what is the current I2? So can somebody tell me how to solve this? Here they said a linear network, linear two-port network. We may think it's two-port network. We can solve by using some what to say, two-port network parameters like Z parameters, Y parameters, or H parameters, ABCD parameters. That is one way of doing. Definitely, that is one way of doing. I feel it is little lengthy and complex. Rather than that, since it is a linear network, we try to use some of the theorems, network theorems, to solve this. Okay. So rather than using some two-port parameters, two-port parameter like any of the parameters, it may be little complex. So we try to use one of the theorems. Since it is a linear network, we will see that. Now if you see here, let us say this is load in this network. If you see, this is load, right? Now we can use Thevenin's or Norton's theorem. Let us say this entire thing you consider network. Okay. So we know Thevenin's theorem what? If we have some complex network, linear network, and maybe here at the output to two terminals, some load is connected, then what? This entire network we can replace with VTH and RTH, right? Thevenin's equivalent voltage and resistance, right? Or ISC and short circuit Norton's current, or RN or RTH. Either Thevenin's or Norton's theorem we can use, right? Okay. Now, if you see this, what I'll do, let us say this I say load, this entire thing I will say the complex network. Now, looking from the load side, so we want to find out the VTH, RTH, or ISC. These things we want to find out, right? That's how the Thevenin's theorem works, right? Now the graph they have given that I will extend a little bit. So the characteristics they have given, I'll try to extend a little bit. So this is V2 minus I2. So 5, this is 4. When it is 5, something like this. If I extend this, somewhere it will touch the 0, this horizontal axis, right? So here it is 4 milliamperes. Okay. Then if you uh, so we have two tip, it's like line, right? We can get the line equation, I guess. This is what 0 comma 5, and this is what 4 milli comma 4 milliamps comma 5 volts. I think somewhere here it will touch at 20 milliamps, it will touch, I guess. 20 milliamps comma 0. We try to find the slope of this. What is the slope for this? 5 minus 4 by 0 minus 4 milli. So 1 by minus 4. Now for this you find out the slope. 4 minus 0 by 4 minus 20 milli. So 1 by half. Fine. Somewhere here 20 milliamps it will touch. Now if you see here, here the voltage is 0. Here if I take voltage and current minus I2, sorry, current is 0 and voltage is 5 amperes. Current is 0 means it's what? Open circuit, right? See, I2 is 0 in this network. If you see, consider in this network, if we consider I2 is 0 means what? It's open circuit, right? Do you agree that when it is open circuited, then only it's 0, right? Yes or no? Right? So I2 is 0 amperes implies terminal 2, sorry, at port 2, it is like open circuited, right? If it is open circuited, that means that is the Thevenin's voltage, right? The open circuit voltage seen from the load terminals, that is nothing but the Thevenin's voltage, right? So what is VTH then? 5 volts, right? VTH is nothing but what? Open circuit voltage that is seen from the load terminals, right? Open circuit voltage that is seen from the load terminal. This is nothing but the VTH, right? So that is what? 5 volts. Already given 5 volts, right? And current is 0, V2 is 5 volts from the graph. Fine. Now the other one, this one you see, the second one you see, here V2 and sorry, reverse I wrote, minus I2 and V2. So if you see here, minus I2 is 20 milliamperes, V2 is 0. So V2 is 0 means it's like short circuit, right? It's a variable load. Resistance is variable one. So you can vary from any range. So here at this point V2 is 0. V2 is 0 means the load terminal is like short, right? Then only V2 is 0. So you assume the load terminal is short. Short means what is the current here? Let us say short circuit current, right? In Norton's theory, you might have seen what is ISC. What is the short circuit current? When the load is removed and you keep a short circuit there, then whatever current flowing through the load is nothing but ISC, right? So in this case, so V2 is 0, minus I2 is nothing but ISC, the current flowing to the load output terminals. So I2 is entering, ISC is nothing but minus I2, right? I2 is entering, ISC is nothing but minus entering, minus I2. That means when V2 is 0 implies port 2, that is load side, is short circuited. Now the current is nothing but from Norton's theorem you have seen, right? So ISC, so I2 is nothing but minus I2 is nothing but ISC. So what is that? 20 milliamperes. From the plot, if we extend the plot, we got ISC 20 milliamps. So what we got is VTH we got 5 volts, ISC we got 20 milliamperes. So we know what is RTH. RTH is VTH by ISC, right? This we know. So VTH is 5 by ISC is 20 milliamperes. So it is how much? 50,000 1 by 4, 250 ohm, right? 5K by 20 by 4, 250 ohm. Now, so according to Thevenin's theorem, we can replace the entire network with VTH and RTH, right? Now, what I will do, I replace the entire network with VTH and RTH, and here you have load. Let us say they have given variable load at port 2. So PTH 5 volts we have, RTH 250 ohm we have. So this entire thing I replaced with that. See this one. Just I'm highlighting here. This entire thing I'm considering a linear complex network. This I'm replacing with the Thevenin's equivalent RTH and VTH. Now what they are asking, at port 2, instead of that, if you replace with this 1 kilo ohm and 10 volts, then what will be I2, they are asking, right? What will be I2? So in this, what I will do, in this, instead of load, this resistance, I replace with whatever they have given in the problem, 250 ohm. At load I am replacing with 10 volts and 1 kilo ohm. 10 volts and 1 kilo ohm. So they have given I2 is this one, right? Entering current from port 2. And now what is I2? I2 is what? Simply we can find out 10. Potential difference is 10 minus 5. The total resistance is 1k plus 250. It is 10 minus 5, 5 by 1250. They are asking in milliamps, right? Milliamps they are asking. So it's into 5 cube milliamperes. So it is 4 milliamperes. Is that okay? Am I anybody else have any doubt in that? So we can use two-port networks, but it is a little complex, lengthy. Maybe better to use either ABCD parameters or hybrid parameters. But instead of that, we can use Thevenin's theorem because they have given these VI characteristics right at the output side. So if because at 5 volts current is 0, it's like short circuit, sorry, open circuit. We can find out open circuit voltage. Similarly, if it's a straight line, if we extend this somewhere at 20 milliamperes, the voltage is 0, short circuit. So we can find out VTH and ISC. From that RTH we can find out either Thevenin or Norton equivalent. You can replace, then we can easily find out whatever the required quantity. Fine. We will move on to another question. So somebody has asked questions, previous year questions from probability, random variables, random process, right? So I have gone through last 3 years, 2022, 2021, and 2020. And from these topics, I got some questions. I will solve those questions. So you see here, two continuous random variables x and y are related as y equal to 2x plus 3. Sigma x square, sigma y square denote the variance of x and y respectively. Then the variances are related as. This I think you know very well. So let us say if x is a continuous random variable, let us say x is a continuous random variable. You know, right, what is the difference between continuous random variable and discrete random variable? Then its mean or average value we will represent as mu x, okay, or expectation of x we will say. This is nothing but sigma, sorry, integral minus infinity to infinity x into fx of x dx. This is called probability density function of random variable, probability density function. Similarly, this is mean or first moment we will say expectation of x. Suppose if you find out expectation of x square, this is called second moment we will say. So expectation of x means here x will come. Expectation of x square is minus infinity to infinity x square into fx of x dx. This is second moment. And variance we will represent with sigma x square. This is nothing but expectation of x minus mu x square. Okay, this is called second moment, second central moment, we will say. This is second moment, this is second central moment or variance, we will say. So expectation of x minus mean, x minus mean square. Mean means e of x. So this you can represent with minus infinity to infinity, uh, x minus mu x square, fx of x dx. If you expand this, later you can expand this, I think already have studied. You will get something like this: expectation of x square minus expectation of x whole square. You will get. Okay, this is variance. That means I can write variance as second moment minus mean square, square of the mean. So this is the variance. Okay, so here what they have given, so some of the properties are there. For mean, variance, there will be some of the properties that you can see later, but it's simple only, don't want to explain them. So y equal to, it is given 2x plus 3. Now if I want to find out variance of y, then what I need to find out? Second moment of y I have to find out, and mean of y I have to find out, right? Now mean of y I will find out, or expectation of y equal to expectation of y means 2x plus 3, right? So this is equal to, actually, yeah, okay, anyway, directly I'm writing, instead of directly writing, you can write minus infinity to infinity. This is what? 2x plus 3 into fx of x dx, right? So linear property, it satisfies the integration. So I can write 2 into minus infinity to infinity x fx of x dx plus 3 minus infinity to infinity fx of x dx. So 2 into this quantity is nothing but mean of x, and 3 into area under PDF, probability density function, is always 1. So this is 2 mu x plus 3. So that's it. Directly we can write expectation of 2x plus 3 is nothing but 2 into expectation of x plus expectation of 3. Expectation, mean of constant is always constant. So 2 e of x plus 3. So this is nothing but mean of y. Similarly, variance of y we will find out. Sorry, e of y square we will find out. Okay. So expectation of y is here 2x plus 3 whole square. So 4x square plus 6x plus 9. Just like earlier, see how I expanded here. Here, the same way you can expand. So it actually, it mean follows homogeneity as well as linearity. It will follow. So this is, you can expand e of 4x square expectation of 6x plus expectation of 9. So 4 you can take common. Okay, expectation of x square plus 6 into expectation of x plus expectation of constant is same, 9. So finally what we got? This one, 4 into expectation of x square. This one we got. Okay. Now what we need to find out. Okay. Variance of y we need to find out. That is what the formula, second moment of y minus mean of y square or mu y square, both are same. So second moment of y just now we found out. What is that? 4e of x square plus 6e of x plus 9 minus expectation of y, we found out 2 into expectation of x, or mean you can say. I'm just writing instead of expectation of x, mean of x. 2 into mean of x plus 3 whole square. So what you get? 4 expectation of x square plus 6 mean plus 9 minus 4 mm, mu x square minus 6 mu x minus 9. So 6 mu x minus 9 plus 9 will get cancelled. So what we got is sigma y square equal to 4 into expectation of x square minus mu x square. Expectation of x square minus mu x square is nothing but variance of x. Already we have seen. So what is the relation? Sigma y square equal to 4 into sigma x square. Okay. So this is the relation from the options. Option B is correct. Suppose if we have y equal to some ax plus b, something like this, or ax plus or minus b, something anything, then always variance of y equal to a square into variance of x. Okay. Any doubts from this? Fine. We'll stop here. It's already time for the other session. Many other questions from random variables probability I have got, and also I'll get some questions from networks. Maybe we'll solve in the next class. As I said earlier, if you have any doubts, you can mail those particular problems to me. I'll try to solve them in the next class. Thank you. Thank you very much.